Let's start today's session. First, write down degree, open a bracket, or we call it order. Degree or order of a polynomial. Degree or order of a polynomial. Under the topic, write down the degree, the degree of a polynomial. The degree of a polynomial is the value is the value is the value of the highest of the highest exponent of the exponent of the exponent of the variable in the expression. Variable in the expression. Okay. Now I will explain what is called degree. Let's get example fx equal to x square plus 3x minus 8. Okay. Testing. This is a we already know how to identify a polynomial function. Now this is a polynomial function. Now we need to find the degree of the function. Okay. Here the variable is x. X is our variable of this polynomial function. Now we call the name, we use the name degree to the highest power, to the highest power of the variable. Highest power of the variable. Here in this term, the power of the variable is 2. In this term, in the first term, power of the variable is 2. In the second term, we already know x means x to the power 1. Then the power of this term, the power of the variable of the term is 1. In the last term, we know 8 can be written as 8 times x to the power 0. Then the power of the variable of this term is 0 because 8 can be written as 8 to the power 8 times x to the power 0. Then power of this term is 0. The power of the variable is 0. Now, what is the highest power that the variable is taken? It is 2. Then we call the degree of this polynomial is 2. Then degree of fx is 2. Okay, let me give another example for you. Let's take fy is equal to y to the power 2027 minus 2 times y to the power 2000 plus 3y minus 5. Okay, here the variable is y. Variable is y. Now we need to find the highest power of the variable. In this term, the power is 27. In the second term, power is 2000. And the third term, the power is 1. Y means y to the power 1. Then first term power is 2027. Second term, the power is 2000. The third term, power is 1. And the last term we can written as 5 times y to the power 0. Then this the last term, power of the last term is 0. The power of the variable is 0. Now we know 2027 is greater than all these values. Then highest power is 27. That means degree of fy is 27. Okay. Write down these two examples. This is the example 1. This is example 2. Here we only need to check the highest power of the variable. Then we give that new name as degree. Okay. Write down those two examples. Now I will give some question for you all. Write down this. Determine the degree. Determine the degree. Determine the degree of the following polynomials of the following polynomials. Okay. Write down those polynomials and send me the answers to WhatsApp. First one is fx equal to Write down these 6 questions and send me the answers via WhatsApp. Okay. Now I will do the questions. Here in the first question, the highest power is, we can see this is the highest power. Then degree should be 8. The first one, highest exponent is 8. Then degree should be equal to 8. In the second question, here the highest power is 6. This is the highest power. Then degrees need to be equal to 6. Second question answer is 6. Okay. Now the third question. Here this is a multiplication. Now the only thing we need to find is the highest power of the variable. Then we can think we need to simplify those brackets to get the final answer. But here if x is equal to x plus 1 times x square minus 3. Okay, we can think here the first term multiply with these two terms, and the second term of this also multiply with these two terms. Okay, here since they only ask for the highest power or the exponent, we can think the highest power should be get by multiplying the highest power of each bracket. This is the highest power term of the first bracket, and x square is the highest power term of the second bracket. Then we can think the highest power should be equal to the term that gives us the highest power is the highest power of the first term, and the term with the highest power of the second bracket. That means x square. We can think the highest power, the term with the highest power should be given by the highest power term of the each bracket. In this bracket, the highest power term is x. In the second bracket, the highest power term is x square. Then we can think the highest power term of the whole simplification is this x to the power 3. Then degree should be equal to 3. Then the answer for the third question is degree is equal to 3. Since they are not asking for every term, they only ask from us ours is degree. Then we do not need to simplify all the expression. We only need to identify the term with the highest power. Okay, we can apply the same theory for the fourth question. Okay, here fourth question is gy is equal to y square plus 3 whole square times 2y minus 7. Then we can think this as a one bracket. Here we can think this is our first bracket. Then we can think gy is like y square plus 3 whole square times 2y minus 7. Okay, here if we simplify this, we can think the highest power term of this bracket is y square whole square. That means y to the power 4. We can simply simplify this in our mind. Oh, here this term is consist of y square plus 3 times y square plus 3. because the square can be written as multiply multiply the same term with it. Then here simply the highest power is y square times y square. That means y to the power 4. The highest power of this, the second bracket is y to the power 1. That is given by 2y. Then we can think the highest power term is y to the power 4 multiplied with 2y. That means 2 times y to the power 5. Okay. This is the highest term with this is the highest power term. Then degree should be equal to 5. Then degree is equal to 5. Since they are not asking for the whole simplification, we just need to identify the highest power term. Okay. The next question is hx equal to 5. Here our variable is x, but here there is no term like x. But we already know 5 can be written as 5 times x to the power 0. 5 times x to the power 0. Now, this is the only term in this polynomial. And the power of the variable is 0. Then degree of this term should be degree of this polynomial should be 0 because the highest exponent or the highest power of the variable is 0. Then the answer for the fifth question is 0. Okay. The last question is if w is equal to w square plus 2w plus 3 times w cube minus 1. Okay. Here, the highest power of this bracket is 2. Then the highest power with term is w square. And the highest power term of the second bracket is w cube. Then the highest term with the highest power will give by multiplying those two terms. Then the highest power term is w to the power 5. Then simply the degree of this also 5. Then degree is equal to 5. Okay. I will give 1 minute to write down those answers. Okay. Write down the next topic. Here first we identify the degree of the polynomial. Now we are going to identify the leading term leading term of a polynomial. Leading term of a polynomial. Write down this topic. Leading term of the polynomial. Under that topic, write down the leading, the leading, the leading term, the leading term is the term, is the term containing the containing the highest power, highest power highest power of the variable, of the variable. Okay, here leading term is we the term, the full term or the whole term that we are get our degree. That means the whole term in the polynomial function with the highest power of the variable. Okay, let me give some example. Think we have fx equal 3x square minus 2x plus 1. Okay, here the highest power is 2. This is the highest power. Then the leading term means the whole term that gives us the highest power. That means the whole term that gives us the degree of the polynomial. Then leading term is leading term is 3x square. This is the leading term. This is the term that gives us the degree of the polynomial. Okay. Now let's another example. Gx equal to 5 minus 2x minus 8 square plus 6x to the power 5 minus 9 to the power x to the power 21. Okay. Here the highest power is 21. Now this is the term that will give us the degree of the polynomial. Okay. Here the leading term is here the leading term is negative or minus 9 times x to the power 21. Here when we getting the whole term, we need to get the sign of the term also. Here the sign of this term is minus 9 times x to the power 21. Let me repeat that. Here we are already know in our definition from the previous day. Here fx means an x to the power n plus an minus 1 x to the power n minus 1 plus, then we continue, and plus a1 x1 plus a0. Here all the terms, between all the terms there should be positive sign. Between all the terms there should be positive sign. Okay, now here in our this example, gx is equal to 5 minus 2x minus 8 square plus 6x to the power 5 minus 9 times x to the power 21. According to our definition, we can rewrite this as 5 plus minus 2x plus minus 8x square plus 6x to the power 5 plus minus 9 x to the power 21. Here, this is, we already know in the definition, all the terms should be, all the terms between all the terms, there should be a plus sign. Okay, now think, this is a one term, this is our second term, this is our third term, this is our fourth term, and this is the fifth term. Now, this is the whole term that gives the highest power. Then here, leading term should be minus 9 times x to the power 21. This should be the leading term. In question, you don't need to write down again this. Like, we do not need to differentiate all the terms with plus sign and rewritten again the question. Simply keeping those definition in our mind and simply give the answer. Now we can think the coefficient should be here when we get the whole term, we simply get that term with the sign. Here we have minus sign. Now here we have also minus sign. Here we have 5 means plus 5. Here we get this term as minus 8 times x square. Here the sign of this term is plus. Then we get plus 6 times x to the power 5. Likewise, do we keeping this in mind, we do not rewritten this again by differentiating each term with plus sign. This can be in our mind. We only need to give this answer. The leading term is minus time x to the power 20. That means we get the whole term. We get the whole term with the sign. We need to keep that mind with the sign. Okay. Write down these two examples. This is the first example. This is the second example. Okay. Now I will give some question. Try to find the leading term of those questions. First one is x is equal to 2x minus 1. Second one is fx equal to 7x square minus 1 times px plus 1 times 1 minus 7 whole square. The third one is gy is equal to 3y minus 1 whole cube times y square minus 1 to the power 4. Fourth one is hx equal to x square minus 1 times 3 minus x plus x to the power 4 x to the power 4. Fifth one is px equal to x cube 4x cube minus 2x to the power 6 plus 1. Write down these 5 equations and send me the answers. Find the leading terms of each polynomials. Find the leading term. I will do the questions. Here, the leading term is 2x. The leading term is 2x. In the second one, there are a few brackets. Here, fx is equal to 7x square minus 1, 3x plus 1 times 1 minus 7x square. Here, to identify the term with the highest power, we need to identify the term with the highest power within each bracket. There are 3 brackets. In here, the term with the highest power is 7 times x square. In the second bracket, the term with the highest power is 3x. And the last bracket, the term with the highest power is minus 7 whole x whole square. Then we can think the leading term or the highest power term is getting by the multiplication of the whole all 3 terms. Then simply we need to multiply those 3 terms. Then we get 7 times 3 times minus 7 times x to the power 2 times x times x to the power 2. Then we can multiply these 3 numbers. We already know 7 times 7 is minus 49 times 3 into x to the power 5. Here 49 into 3 means minus 147. Then this should be the leading term of the second question. Okay. Likewise, in the third question, there are also some brackets. Now, we need to identify the highest term of each brackets. 3y minus 1 whole cube y square minus 1 to the power 4. Okay. Here, highest power of this bracket is highest term is in this bracket is 3y. That means we can think this is the 3y, and for this bracket there are the power of this bracket is 3. Then we can think the term with the highest power should be get with the highest term in the bracket need to be the power of that bracket is 3. That means the power of the highest term should be 3. Then we can think finally we have the highest power in the whole bracket. In the whole bracket should be 3y into 3. Similarly, for whole this bracket, we can think highest power of the bracket is y square. Then that should be also the power of that bracket is 4. That means we can think the highest power term can be given by this. That means y to the power 8. Then the highest power is, the highest term is 3 to the power 3 times y to the power 3 times y to the power 8. That means 27 times y to the power 11. This is the highest term of the third polynomial. Simply, we get the highest term of the bracket and we give the bracket, the power of the bracket to the that term. Okay. In the fourth question, the question is hx equal to x square minus 1, 3 minus 2x plus, sorry, square minus x plus 2x to the power 4. Then the highest term of this bracket is x square, and the highest or the leading term of this bracket is 2 times x to the power 4. Then the highest term should be given by multiplying those two terms. That means 2 times x to the power 6. Then this is the leading term. This is the leading term. In the last question, the term with the highest power is this. The term with the highest power is this. Then leading term should be the term minus 2x to the power 6. Here we get the whole term with the sign. I already mentioned in the previous example, we need to get the whole term with the sign. This is the leading term. Okay, write down those answers. Now write down a topic, coefficients. Coefficients. Write down topic, coefficients. I think you already heard this name in your O levels also. Okay, write down the topic, coefficients. Under that, write down coefficient. A coefficient is the numerical part numerical part is the numerical part is the numerical part of a term. Yeah. Under that, write down when 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 ask for the when ask for the coefficient of a specific coefficient specific power of the variable power of the variable power of the variable, comma, comma, we are looking for the number with the sign, number with the sign, number with the sign multiplied by that power of the variable, multiplied by that power of the variable. That means, let's get example fx equal to 3x square plus 5x plus 6. Okay, here this is a one term. This is our second term. This is our third term. Now, when we get our first term, this is 3 times x square. Then this is the variable term. We say the coefficient, the term or the number or a numerical part of this whole term. That means this variable is multiplied with the 3. This is the numerical part that multiply with the our variable term. That means here 3x square means 3 times x square. Or simply we get the numerical part that consists of that is with the our variable term. That means coefficient 3x square is equal to 3. The term, the number that multiply with the variable in our second term is 5x. Then we can simply say coefficient of 5x is equal to 5. Okay, let me give another example. Think we have gy is equal to 4y cube minus 8y square plus 7y to the power 4 minus 9y to the power 5. Let's think we have this kind of polynomial. Then if we get this term, the coefficient of 4 times y cube is 4. Simply the numerical part of that term. Here, this term is, I have already mentioned, when we get the whole term, we need to get with the sign. Then the second term should be not 8y square. Simply it should be minus 8y square. We need to get the whole term with the sign of that term. That means coefficient of the second term is minus 8y to the power 4, y to the power 2. That means coefficient of it is simply minus 8. The number that multiply with the variable term. Then the coefficient of 7 times y to the power 4 should be equal to 7. The number multiplied with the variable term. Then simply the last one, coefficient minus 9 to the power 9 times y to the power 5 is equal to minus 9. The numerical part of the term. Simply it is minus 9. Okay. Now I will give 2 minutes to write down those two examples. Write down those two examples. Now write down this special note. This is very important note. Write down. After writing down, I will explain. If a term, if a term if a term if a term does not appear in the polynomial appear in the polynomial appear in the polynomial appear in the polynomial its coefficient its coefficient its coefficient is considered is considered to be zero to be zero to be zero. This is very important note. If a term does not appear, then we can think the coefficient of that term is should be a zero. Let me explain with the simple example. Think we have a polynomial function called 6 times x to the power 4 minus 3x to the power 3 plus 5x plus 7. Okay. Now the coefficient 6x to the power 4 term is plus 6. Likewise, coefficient of this term is equal to minus 3. Now think someone asked from you all what is the coefficient of what is the coefficient of x square. Now someone asked from you what is the coefficient of x square. Now when we inspect this function, there is no term like x square. There is no term like x square. That means there are no term with the variable x and is power 2. But we can simply rewritten this polynomial as like this: 6x to the power 4 minus 3x to the power 3 plus 0 times x square. 0 times x square. We already know 0 times some value is 0 plus 5x plus 7. Okay. We already know there is no term with the x square. In the first given question, there is no term with the x to the power 2. But we can write a term with the x to the power 2 by multiplying it with 0. Because we already know 0 times some number is 0. Then now we can say coefficient of coefficient of that term or x square should be equal to 0. If there is a, if now you can understand this definition. If there is a does not appear, if a term does not appear in the polynomial, then we can simply say the coefficient of that term should be equal to 0. Okay. Now I think you can understand that. Okay, write down this example also. If a term does not appear in our polynomial, then we can say the coefficient of that term should be equal to 0. That is important note you need to keep in your mind. Okay, write down this example. Okay, now write down topic: leading coefficient. Leading coefficient. Leading coefficient. Write down under this the coefficient, the coefficient of the coefficient, the coefficient of the coefficient of the leading term of the polynomial. Leading term of the polynomial. Leading term of the polynomial. Okay. Now we need to identify the leading coefficient. To identify the leading coefficient, first we need to identify the leading term. First we need to identify the leading term. Then from that term, we can identify our coefficient of that leading term. Then we call that coefficient as leading coefficient. First, we need to identify the leading term. Then we can identify the leading coefficient. Okay, let me give some example for that. Think we have fx equal to 5 minus 2x to the power 6 plus 3x square minus 7x cube. Okay, now think we need to identify the leading coefficient. Leading coefficient. First, we need to identify the leading term with the sign. Now we already know this is the leading term. Then leading term is equal to leading term is equal to negative 2 times x to the power 6. Then what is the coefficient of this term? The coefficient of this term is minus 2. Coefficient of this term is minus 2. Then this is equal to leading coefficient leading coefficient of the polynomial. First, we need to identify the leading term. Then the coefficient of that leading term is called leading coefficient. Okay, write down this example. Simply, first we need to identify the leading term. Then the coefficient of that term is called leading coefficient. Write down the next topic. Constant term. Constant term. Write down the next topic. Constant term. Constant term. Under that topic, write down the constant term. The constant term is the term with no variable. With no variable. With no variable. Open a bracket and write down equivalent to x to the power 0. Equivalent to x to the power 0. That means variable power is 0. Okay. Write down under the bracket equivalent to x to the power 0 or variable to the power 0. Okay. Let me give example. Think we have fx equal 2x plus 3. Then what is the term without the variable? This is the term without the variable. Then we call this term as constant term of the polynomial. The term without the variable or simply we can say this is equal to 2x plus 3x to the power 0. Or someone can say the coefficient of the x to the power 0, or the coefficient of the x to the power 0. Someone can say like that, or someone can say the term that is without the variable. The term without the variable. Constant term, someone can say the term without the variable. Without the variable. Let me give another example. Fx equal 2x to the power 6 minus 5x plus 7. Then the term, let me give minus 7. Then the term without the variable is minus 7. The term with the sign. Then the constant term is equal to negative 7. Okay, write down those two examples also. Now I will give an exercise for you all. Do the exercise and send me the answers. Exercise is for the following polynomial functions, identify the number one degree, number two leading term, number three leading coefficient, number four constant term. For the following polynomial functions, try to identify the degree, leading term, leading coefficient, and the constant term, and send me the answers. First one is fy is equal to 2026 y to the power 2027 minus 9 y cube plus 5. Second one, fx equal to 3x cube plus 5x square plus 2 times 2x square minus 7x minus 3. Third one is fx equal to 3x plus 7 square times 4 minus 5 x square. Okay, do these three equations and send me the answers. Before solving those three equations, I will give another question for you all. The student who are finishing already these three equations, try to answer this question. This is based on your O-level knowledge. This is the question. Let fx is equal to p x square plus qx plus 3. This whole question is based on your O-level knowledge on about the functions. Here f2 is equal to 2 times f minus 1. Simply 2 times f minus 1 plus 5. And 3 f1 is equal to f2 plus 5. Find the values of p and q. Find the values of p and q. The whole question you can answer based on your O-level knowledge. Here the function is px square plus qx plus 3. They are given that f2 is equal to 2 times f minus 1 plus 5 and 3 times f1 is equal to f2 plus 5. Based on those data, try to find the values of p and q. Okay. The students who are already finished those three questions, try to answer this question. Now I will going to explain the answers for the previous question. Here first question is fy is equal to 2026 y to the power 2027 minus 9 y cube plus 5. Okay, we need to find degree, leading term, leading coefficient and constant term. Here degree means the highest power of the variable. Then here highest power is 2027. Then degree is 2027. The second one is we need to find the leading term, the whole term with the highest power. That is 2026 times y to the power 2027. The third one is coefficient of that term. That means leading coefficient. Here leading coefficient is 2026. Then our last question is constant term. The term without the variable is here 5. Then constant term is 5. Okay. Those are the answers for the part A question in part A. Now let's try to find the answer for the part B. Here the question is fx equal to 3x cube plus 5x square plus 2 times 2x square minus 7x minus 3. Okay. Now we need to identify the leading term to get the degree, leading term, and the leading coefficients. Here we already discussed about those things. The highest term, highest power term or the leading term of this bracket is 3x cube, and the leading term of the second bracket is 2x square. Then the whole leading term should be get with the multiplication of those two terms. That means 6 times x to the power 5. Then the degree should be 5. Then the leading term should be 6 times x to the power 5. Then leading coefficient should be the coefficient of the leading term is 6. And now we need to find the constant term. Here we can think the final constant should be get by the multiply the constant of the each bracket. Here in the first bracket, the constant term is plus 2. Here in the first bracket, constant term is plus 2. In the second bracket, constant term is negative 3 or minus 3. That means multiplication of those two terms need to give the constant term of the whole function. That means negative 6. Then the constant of the whole polynomial is negative 6. Those are the answers for the part B question. Then let's try to solve the next question. It is fx is equal to 3x plus 7 whole square times 4 minus 5x square. 4 minus 5x square. Okay. Similar, like the previous question, we can think we need to find the highest term of the whole bracket, and also we need to find the highest term of the second bracket. Here, highest term is simply can be get by the highest term of this is the leading term of 3x, then 3x whole square. Then the highest term of this term or leading term of this bracket is minus 5x square. Then the whole leading term should be get by multiplying those two terms. That means 9x square times minus 5x square. That means minus 45x to the power 4. Then simply we can write degree of this polynomial is 4. Then the leading term is minus 45 times x to the power 4. Then leading coefficient is minus 45. Now we need to identify the constant term. Here simply like the previous question, we can think the constant term should be get by the multiplication of the constant of each brackets. Here in the first bracket, the constant term is 7. And here the whole bracket has a square term. Then we can think 7 should be also square. In the second bracket, the constant term is 4. Then the final constant sum should be 7 whole square times 4. Then this value is 49 times 4. That means 196, and the sign is positive. Then the constant term is 196. Okay, I will give 2 minutes to write down those answers. After writing down those answers, try the question that given by me, this question, and send me the answers through the WhatsApp. First, write down the answers for the previous 3 questions. Before doing the next question, I will explain how to substitute values for our functions. Here, let's think we have a function called a polynomial function fx equal to 2x plus 7. This is our function. Here, inside the bracket, we have the variable x. Inside the bracket, we have variable x. And in our function, here, we have a variable. Okay. Now think we have to find f inside the bracket 2. Inside the bracket 2. Here we can see previously inside bracket we have the term x. Now inside the bracket we have a numerical value 2. That means we can think x is substituted by number 2. X is substituted by number 2. That means we need to put 2 whenever we find the term x. Whenever we find a term x, then we need to substitute that value. That means 2 times. Here we have found x. Now we need to substitute value 2 because previously we have value x in our bracket. Now we have number 2. That means we can think x is replaced by number 2. Then plus 7. That means 4 plus 7. That means 11. Then we can think f2 is equal to 11. That is very simple. Let me repeat another example. Think we have fx equal to 3x cube x square minus 5x plus 8. Let's think we have a polynomial like 3x square minus 5x plus 8. Now think we need to find the value f3. F3. So let's think we need to find value f minus 2. F minus 2. That means previously in our bracket, inside the bracket, we have the term x. But now inside the bracket, we have term minus 2. Then we can think x is replaced by minus 2. Then we need to put minus 2 instead of all the terms with x. That means here 3 times x square. Then x square means negative 2 whole square because x is replaced by minus 2. Then we have minus 5. Then again we have x term. Then we can replace that term with negative 2 plus 8. Then we need to simplify this. Then we get 3 times minus 2 is square means 4. Minus 5 times minus 2 is plus 10 plus 8. Then we have 12 plus 10 plus 8. That means 12 plus 10 is 22. 22 plus 8 means 30. Okay, let me repeat another example. Let's think we have gx equal to 4x cube minus 7x plus 10. Now think we need to find the value g3. Now simply previously in the bracket we have term x. Now inside the bracket we have term 3. That means we need to substitute the x with value 3. Then we can find the value of g3 is 4 times in instead of x. Now we write 3. Now we substitute 3 for the x value. Minus 7. Now we instead of x, now we write 3 plus 10. Then we get 4 t to the power 3 means 27. Minus t to the power 3 times 7 means 21. plus 10. Then we get 4 times 27 means 108 minus 21 plus 10. Then the final answer we get 108 minus 11. By simplifying this 21 and plus 10, we get minus 11. That means we get 97. Okay. Now think we need to find G0. G0. That means instead of x, now we substitute 0. That means 4 times instead of x, now we substitute 0. Minus 7 instead of x, now we substitute 0 plus 10. That means 4 times 0 to the power 3 is 0 minus 7 to the power 7 to times 0 is 0 plus 10. Now the value is 10. Very simple. Instead of x, we replace the number that inside the bracket. Okay. Write down those examples. After writing down all the examples, try to finish the previous question. The students who haven't done the previous question, try to done that question after finishing this. After finishing, write in those examples. Simply, instead of the variable, we need to put the value. The variables will be x o, y o, w o, anything. We simply need to replace the variable with the number inside the bracket. That is the simple, very simple theory. Okay, now I will try to solve this question. Here we are given fx equal to p x square plus qx plus 3. Okay, we need to find first we need to find the value of f2, f minus 1 and f1. Then we can substitute the given equation and try to solve. Okay, first we try to find the value of f2. Then f2 means p times, we simply substitute the value for the variable. Then 2 to the power 2 plus q times 2 plus 3. That means 4p plus 2q plus 3. Okay, this is the value of f2. This is the value of f2. Okay, now we try to find the value of f1. Value of f1. f1 means p times 1 square plus q times 1 plus 3. That means p plus q plus 3. Okay, that means f1 equal to p plus q plus 3. This is the value of f1. Now we are trying to find value of f minus 1. F minus 1. Simply we substitute the variable with minus 1 whole square plus q times minus 1 plus t. That means p times minus 1 whole square means 1 minus q plus t. That means f minus 1 is equal to p minus q plus t. This is the value of f minus 1. Now they are give some data. What they give us? First they give f2 is equal to 2 times f minus 1 plus 5. Now we are already find the value of f2 and f minus 1. Then we need to substitute those values. Here f2 means 4p plus 2q plus 3. This is the value of f3. It is equal to 2 times the value of f1. f1 is f minus 1. F minus 1 is p minus q plus 3. This is here 2. F minus 1 is we need to multiply the 2 with the value of f minus 1. This is the simple definition of 2 times f minus 1. First we need to find the value of f minus 1. Then the whole value is need to multiply with number 2. Here this is 2 times f minus 1. So this is simply 2 times f minus 1. Okay, plus 5. Now we can further simplify this equation. Here 4p plus 2q plus 3. Now we can simplify this bracket. Then we have 2p minus 2q plus 6 plus 5. Now we keep variable in one side, then constant term in the other side. Then simply 4p plus 2q. Then this 2p going to left hand side, then minus 2p. This minus 2q go to left hand side, then it gives plus 2q equal to 6 plus 5 is 11, and here plus 3 is going to right hand side, that means negative 3. Then we can further simplify these 4p and minus 2p. It gives 2p, and further we simplify plus 2q and plus 2q, that gives plus 4q is equal to 11 minus 3 is 8. Now further we can simplify this by dividing both sides with plus 2. Then in left hand side p plus 2q is remain, and the right hand side 4 is remain. This is the first equation that we will get to find the values of p and q. Okay, this is the first equation. Now they are also give us 3 times f1 is equal to 3 times f1 is equal to f2 plus 5. f2 plus 5. Here I have told this. This means 3 need to multiply with the value of f1. So this is equal to 3 times f1. So this is equal to 3 times f1. We can use any definition. Simply multiply 3 with the function value of f. That means we get 3 times we have found that f1 value is p plus q plus 3. P plus q plus 3 is equal to, here we have f2 value. F2 is 4p 4p plus 2q plus 3. This is the value of f2 plus 5. This is the value of f2 plus 5. Now we can simplify this bracket. Then we have 3p plus 3q plus 9. In the right hand side, we have 4p plus 2q plus 8. Then we can get all the variables into one side and all the constant term into other side. That means 3p here and 4p went to this side and gives us minus 4p. Then 3p minus 4p plus 3q already here. Then this plus 2q need to move to left hand side. Then it gives minus 2q. We have remaining 8 in the right hand side. Then we simply move the constant term to the right hand side. Then we have minus 9. Then this further simplifying gives minus p. This simplifying gives plus q is equal to minus 1. 8 minus 9 is minus 1. Then this is the second equation. Now we can simplify those two equations and get the values of p and q. Simply by adding the first equation and the second equation, we can get the value of q, because here when in the left hand side we have p plus 2q minus p plus q, and on the right hand side we have 4 minus 1. Then these two terms are cancelled out, and in the left hand side we have 3q and the right hand side we have 3. Then we have q is equal to 1. Now we need to find the value of p. Here on the equation 1 we have p plus 2q is equal to 4. That means p is equal to 4 minus 2q. That means 4 minus, we have found that q is equal to 1. 2 times 1. That means p equals to 2. Now we have found the values of p and q. Okay, now I will give 2 minutes to write down the answers. I done this. I will scroll down after 1 minute. Okay, write down the next topic. Identical polynomials. Identical polynomials. Write down next topic. Identical polynomials. Under that topic, write down two polynomials. Two polynomials two polynomials two polynomials are identical are identical are identical if they are equal if they are equal if they are equal for all possible for all possible for all possible all possible values of their values of their variables values of their variables. That means if we have two polynomials, if we plug a certain value for those two polynomials, then in every time those two polynomials need to give us the same value. That means for any value, those two polynomials should be equal. That means they need to give the same value. For example, if we say fx and hx is identical, then if we get f0 as 5, then h0 also should be give the value of 5. If we get f1 is equal to 10, then h1 also equal to 10. If we get f minus 2 is equal to 3, that means h minus 2 also need to equal to 3. If we get f3 is equal to 7, then h3 also need to equal 3. Likewise, this need to be true for any number. That means no need to integer, like any number. F to the f half is equal to 7. So, let's say 2. Then h half also need to equal 2. If f negative 3 over 4 is equal to 5, then h negative 3 over 4 also need to equal 5. That means both function need to give the same value, need to give the same value for all the numerical values, for all the real numbers. So we can say all the real numbers, for all the real numbers. Okay, write down this also. This is what we say in our definition. For any value we plug into those two functions, if they are identical, if fx and hx are identical, then both need to give the same value for any real number. Okay. Write down this example. After writing this, write down again. Two polynomials two polynomials, let's say fx and gx, x and gx are identical identical are identical if and only if and only if and only if and only if the coefficients the coefficients the coefficient of the corresponding of the corresponding powers of the variable powers of the variable powers of the variable in both polynomials in both polynomials in both polynomials are equal are equal. Take 13 seconds and read this by your own and try to understand. I will explain after that. Here we can simplify this to if we get two polynomials and if we say both are identical, then the degree of those two should be equal. Then degree of both polynomials are equal. That is the first condition. Degree of the both polynomials need to be same. And the second one is corresponding corresponding coefficients are also equal. Corresponding coefficients are also need to be equal. That means, let's say we have a function, a polynomial fx, and it is equal to a times x to the power 3 plus b x to the power 2 plus cx plus d. Let's say this is the one polynomial. Now let's say we have another polynomial gx equal to pxq plus qx square plus rx plus s. Let's say we have another polynomial. Here, to define the identical, if the two polynomials are identical, we use the symbol three lines. Similarly, like for equal sign, we use two lines. Likewise, for identical symbol, for identical sign, we have used this symbol. This is the symbol for identical, identity. This is the symbol for identity. Now, if someone say fx is identical to gx, Like here, the polynomial fx identical to polynomial gx. That means we need to check these two conditions. Then degree should be equal for both polynomials. Here, fx degree is 3, the highest power of the x variable, and this term degree also equal to 3. The first condition for identical polynomials, degree should be equal. The second one is corresponding coefficients must be equal. That means corresponding coefficient means here the coefficient of x cube is a. Then to both the identical polynomials, a should be equal to p. A should be equal to p. And b should be also equal to q. And c also need to be equal to r. And d also need to be equal to s. That means corresponding coefficient need to equal. Here x square coefficient is plus b. Here x square coefficient is plus q. Then those two need to equal. Here coefficient of the x is plus c. Here coefficient of the x is plus r. Then this need to be equal. Here the constant term is d. Here constant term is plus s. Then this should be equal. All the coefficient must be equal. That means all are conditions with n. That means every term, every corresponding coefficient should be equal. Here we have four coefficients. If we have four coefficients, then all the four corresponding, all the four corresponding coefficient need to be equal. Need to be equal to become both those polynomials to become identical. If these two are identical, all the coefficients should be equal to each other corresponding coefficients. Okay. Write down this also, those terms that I explained. This is a very important theory for our upcoming lessons. I have now, if two polynomials are identical, then we have already found that all the coefficients should be equal to each other corresponding coefficients. Also, we can say if two polynomials are identical, then for any k belongs to real numbers, we can say fk is equal to gk. That means we have already found that if we substitute any value for x, then those two also need to be equal. That means f0 is equal to h0 if they are identical. Likewise, if fx and gx polynomials are identical, then we can say if we replace x value with the numerical value k, then those two also need to be equal. That means f1 need to be equal to g1, or we can say f minus 1 need to equal g minus 1, or we can say f half need to equal g half, or we can say f negative 7 over 2 need to equal g negative 7 over 2. That means if we replace the variable with the number, then both sides need to be equal. That means fx identical to gx imply fk equal to gk for any k belongs to real number. Okay, write down this also. Those are very important results that we are going to get for solving in upcoming questions. If two polynomials are identical, then we can substitute any value and equal both functional values. Okay, now we are going to solve some examples. First, okay, let's get fx equal to ax cube plus b minus 1 x square plus cx plus d, and get gx equal to 2x cube plus 6x minus 3. 6x minus 3. Write down the question. If fxn, if fxn gx are identical, if fxn gx are identical, if fxn gx are identical, comma, find find values of a comma b comma c comma d. Write down the question first. Fx is equal to this, gx is equal to this. Then our question is, if fx and gx are identical, find the values of a comma b comma c comma d. First write down the question, then I will explain how to do this kind of questions. Okay, now there gives us both two polynomials are identical. That means fx is identical to gx. That means ax cube plus b minus 1 x square plus cx plus d is identical to 2x cube plus cx minus 3. That means this is one side of the identical, and this is the other side of the identical. Then if these are identical, simply we can say corresponding coefficients need to be equal. That means if we say for x cube, for x cube, here in the left hand side coefficient is a. In the left hand side coefficient is a. On the right hand side coefficient is 2. That means both are need to be equal to become identical. That means a is equal to 2. Then if we consider for x square, on our left hand side, the coefficient of x square is b minus 1. The coefficient of x square is b minus 1. In the right hand side, there is a no term called x square. There is a no term called x square. That means the coefficient of x square should be 0. We have already learned that. That means if there is no term, then the coefficient should be 0. Then in the left hand side, coefficient is b minus 1. And on the right hand side, coefficient is 0. Then this gives b is equal to 1. We can simplify this and get the value b is equal to 1. Then if we solve for x coefficient, on the left hand side we get c. And on the right hand side we have coefficient of x is 6. That means c equal to 6. If we go for the constant term, for the constant term, on the left hand side we have value d, and on the right hand side we have the coefficient constant term as -3. That means d is equal to -3. Okay, I think you have understand this. Okay, first write down this, then I will give a question to you. Okay, okay. After writing this, try to solve this question. A times x plus 3 plus b times x minus 1 is identical to 3x, is identical to 3x. Okay, try to find the values of a and b. Try to find the values of a, b. Here, these two are identical. then find the value of AB. Okay, after writing the previous example, try this question by your own and send me the answers. Okay, now I will explain the question. Here we need to find the values of AB. Okay. In right hand side we have 3x. In left hand side we have a times x plus t plus b times x minus 1. Okay. Now we have ax plus 3a plus bx minus b identical to 3x. Now the final x term is, we need to add those two terms to get the final x terms. That means a plus b x is there. And we have those two are constant terms. That means for constant we have 3a minus b. Let me repeat. Before do the identical operation, we need to find each coefficient, the final coefficient of each terms. That means the final coefficient of x is a plus b. The final constant term is 3a minus b. After that, we can apply our rule. That means for coefficient of x, here left hand side we have a plus b. On the right hand side we have 3. And for the constant term, for constant term, on the left hand side we have 3a minus b. And on the right hand side there is no constant term. That means plus 0. Then here plus 0. Then we need to solve those two simultaneous equations and get the values of a and b. Here a plus b equal to 3, and here 3a is equal to b. Then we simply substitute b by 3a. Then we can apply here. That means a plus b means 3a equal to 3. That means 4a is equal to 3. That means a equal to 3 over 4. Then we can substitute here. Then we get b is equal to 3a. That means b equal to 3 times 3 over 4. That means b is equal to 9 over 4. Okay. Before applying the rule, first we need to identify the final terms of each x values. That means this is the final term. This is the final term. Then we need to apply the rule. Okay. Write down those things. And I will give another question to write to solve by you. 2x square minus x plus k is identical to p minus 1 x square plus qx minus 3. Try to find the value k, p, and q. After writing the previous answer, try to do this question by your own and send me the answers. I will solve this question. Here was we have on both sides final coefficient are already given. Then we don't need to further simplify. Here for x square we can get in the left hand side 2 and in the right hand side p minus 1. That means p equal to 2 plus 1. That means p equal to 3. For x square we can get the value of p. For this term here we for x square We can also use x square with the two inequality sign. This is the symbol for finding the corresponding coefficient. Either you can write for x square or simply you can this symbol and do the operations. Let me repeat. Either you can say for x square and find the values, or simply put x square and put two inequalities, and then you can compare those two sides. 2 is equal to p minus 1, then 2 plus 1 is equal to p, that means p equal to 3. Either you can say for x to the power n, or simply use xn and include these two this side, that means two inequality signs. This is same as for xn. Similarly, like we can use x, then this sign, and tell in left hand side we have minus 1 and left right hand side we have q. That means q equal to minus 1. Or someone can say for x, then apply this and q equal to minus 1. Then someone can say for constant term k is equal to negative 3. Or we can say x to the power 0. This means the constant term, and put k is equal to negative 3. Okay. Write down those things and I will give a little bit harder question than this. Try that question by your own and send me the answers via WhatsApp. First, write down the answers for this, and after that, do this question by your own and send me the answers. This is little bit different, little bit difficult. A square 2x plus 1 plus 2px times x minus 1 plus x minus 1 whole square is identical to, in the right hand side we have x square qx plus 4 minus wx plus 1. Find the values of p, q, and w. In the left hand side of the identical sign, we have x square times 2x plus 1 plus 2px times x minus 1 plus x minus 1 whole square. On the right hand side, we have x square times qx plus 4 minus wx plus 1. Try to find pqw. I will give 2 minutes for this. After doing, send me the answers via WhatsApp. Okay. I will explain the question. Here, before evaluating the corresponding coefficient, first we need to find the final coefficient of each terms. That means we need to simplify both sides. Okay. Now, if we get the left hand side, we can simplify for this. Our left hand side is x square 2x plus 1 plus 2px x minus 1 plus x minus 1 whole square. This is further can simplify 2 times x cube plus x square. And this can be further simplified plus 2px square minus 2px. Simply simplify the brackets. Here we already know how to expand this bracket. That means square of the first term plus square of the second term minus 2 times multiplication of those two terms. Then further we can simplify this. Here we have x cube term. There are no further x cube term. That means final x cube term is 2 times x cube. Then here we have x square term. Here also we have x square term. And here also we have x square term. Then to get the final x square term, we need to add up those x square terms. That means we have plus for x square term, we have here plus 1 plus 2p plus 1. Let me repeat. Here the first x square term is 1 times x square. Here the second x square term is 1 times x square. So I may further write this. Here we have x square plus 2px square plus x square. Those are the all x squares term. Then we have terms with x. Here we have minus 2px. Here we have minus 2x. Okay. Then here we have a constant term 1 square. That means plus 1. Now here we have 2x cube. Plus here if we get x square out from these expressions, these terms, then we have plus 1 plus 2p plus 1. And if we factor out x from these two terms, then we have plus x. Inside the bracket, we have minus 2p minus 2. And we have constant term 1. Okay, that means first in the left hand side polynomial, we can simplify 2x cube plus x square times 2 plus 2p plus x times minus 2p minus 2 plus 1. Okay, this is the left hand side. We have simplified further our left hand side. Now, likewise, similarly, we need to simplify our right hand side. In right hand side, what we have was x square times qx plus 4 minus wx plus 1. That means we can further simplify this. Q times x cube plus 4 times x square minus wx plus 1. Here already all the terms are differentiate each other. Now this is our final right hand side. Okay. Now in the left hand side we have 2x cube plus x square 2 plus 2p. Okay. Since numerical parts we can write in front of the variable, we can say 2 plus 2p x square plus minus 2p minus 2x plus 1. This is our left hand side polynomial. And this is identical to our right hand polynomial is q times x cube plus 4x square minus wx plus 1. This is the polynomial of our right hand side. Now we can compare the corresponding coefficient. Then if we get x cube coefficient, we get 2 is from the left hand side and the q from the right hand side. Then q is equal to 2. And from our coefficient of x square, on the left hand side polynomial, we have 2 plus 2p. 2 plus 2p. On the right hand side polynomial, we have 4. Then 2p is equal to 2. That means p is equal to 1. Okay. Now we need to find the value of w. when we compare the coefficient of x on the left hand side polynomial, we have 2p minus 2. On the right hand polynomial, we have minus w. We already found p is equal to 2. That means here in the left hand side, we can simplify minus 2 minus 2. And here right hand side minus w. Then minus 4 is equal to minus w. That means w is equal to 1. Now we have already found the values of, w is equal to 4. Minus 4 is equal to w, then w is equal to 4. Now we have found the value of p, q, and w. Before try to evaluate the corresponding coefficient, first we need to simplify the final polynomial, which each terms separately. Then we need to put our rule, put the corresponding coefficient and find the values. Okay, I will give 2 minutes to write down this. Start to write down this. Now I will give the final question for the day. A times x minus 1 times x minus 2 plus b times x minus 3 times x plus 1 is equivalent to x square minus x plus c. Find the values of a, b, and c. This is the final question for the day. A times x minus 1 into x minus 2 plus b times x minus 3 into x plus 1 is equivalent to x square minus x plus c. Try to find the values of a, b, c and send me the answers. I will give 3 minutes for this question. Okay, I will explain the question. Here in the left hand side, we have the polynomial a times x minus 1, x minus 2 plus b times x minus 3, x plus 1. Then we can further simplify this as a times x square minus 3x plus 2. Here, this multiplying, we get x square and minus 2x minus x plus 2. Likewise, in here, we get b times x square minus 2x minus 3. That means we get a plus b x square minus 3a minus 2b times x plus 2a minus 3b. This is the polynomial on the left hand side. On the right hand side, we get x square minus x plus c. Okay. Then we need to match the corresponding coefficient. When we consider x square coefficient, we get a plus b equal to 1. And if we match up the coefficient of x, then we get minus 3a minus 2b equal to minus 1. And when we compare the coefficient of x0, that means constant term, we get 2a minus 3b equal to 6. Okay. By solving these two equations, we can get the values of a and b. Then we can plug those values into this equation and we can get the value of c. Okay. We have a plus b equal to 1 and minus 3a minus 2b equal to minus 1. This is equation 1. This is 2. Then if we multiply the first equation with by 2 and add up the second equation, we get 2a minus 3a is equal to 2 minus 1. Here simply multiply this with 2. Then we get 2a and 2b. Then those 2b and minus 2b cancel out. Then we get minus a equal to 1. That means a equal to minus 1. Then we can substitute it for the first equation. That means a plus b is equal to 1. That means b equal to 1 minus a. That means 1 minus a means negative 1. That means 1 plus 1 equal to b is equal to 2. Then we already know 2a minus 3b is equal to c from this equation. Then we get 2 times minus 1 minus 3 times 2 is equal to 6. That means minus 2 minus 6 is equal to c. That means c is equal to minus 8. Okay, write down this answer.